Right. Turning effect of force. Or we term it as the moment. M-O-M-E-N-T, moment. Right? Turning effect of force. This is chapter number 11. Okay. 9th we did. Now we are starting up with the 11th one. So what is this turning effect? Okay. By applying a force. What we can do is we can move the object. Or we can stop the motion of an object. Let's say moving the object. You apply the force here. Object will be moving to the direction of the force. Moves to the direction of force. What is the direction you apply the force? It moves to that direction. Right? What is the direction you apply the force? That direction it moves. Correct? So that is just giving a force. Okay? About that force in the previous lessons we learned. Unbalanced force, the Newton's law we learned, friction we learned, resultant force we learned. Now we come for something different. That is the word moment. What is this moment? It is not just force, but the same rod. I'm gonna take it. One end is free and the other end is fixed. Okay. Let's say this is the point where it is fixed. It is fixed over there. It is bolted over there. Now, when you apply the same force here, you apply the same force here. Would it be completely moving? Tell me. It was there freely, you applied the force, it moved down. Now it is clamped. It is pointed, it is fixed here. When you apply the force, can it move completely like this? No. What happens then? No. Use the word. It rotates. It turns. Okay, it won't move completely down. It's not a complete motion down, but rather around the point it would be turning. It gives a turning effect. This happened because you are applying a force at a distance. You are applying a force at a distance. This distance d. So you see there are two physical quantities. Earlier only one quantity was there, which is the only force, but here force and distance, two quantities are there. So because of this, what happens is on the same line of action, the object will be moving. Right? So this is what we name as the turning effect. What effect it is? Turning effect. So this is called the turning effect. Turning effect. For this turning effect, we are giving a word. For this turning effect, we are giving a word. What is the word we are giving? It is what we name as the moment. Turning effect is what we name as the moment here. So how do we find out the moment? Moment to be found, we use two quantities, that is force and distance. So moment is equal to force into what is the distance we take? Perpendicular distance. Okay, perpendicular distance. And this perpendicular distance is taken between 2 points. Always remember these 2 points. What are the 2 points? One is the line of action of the force. Line of action of force. Where the force is acting. This is the line where the force is acting. Okay, so that is a line we have to take. And the other one where it is fixed. That is called the pivot. Okay. Oh, it is the axis of rotation. Axis or a point or a bar around which it is rotating. Okay. Now let's say I'm rotating it. I'm moving around this joint. So this is the pivot. Where the forces are applied somewhere here, let's say. So this is the distance. Perpendicular distance. So force into perpendicular distance is what the moment is. So I can write it symbolized. Moment equals F into D. We don't use a symbol for this moment. Is that clear? Okay. So is that clear about the fact? Moment is equal to F into D. F into D. So force into distance is a term as moment, and we are going to take this note down on your writing. So take the topic, turning effect of force, and please write it over there. Yes, yes. These no need to write this. Don't write this part. Don't write. I asked you to write this down. Okay? On your writing book. Start from it. Heading is given by turning effect. Unit 11, turning effect of force. You can mark this down. So this is the formula. Okay? Moment is equal to force into distance. And remember, force is measured in newtons. Always newtons. Distance is measured always in meters. So the answer moment will be in Newton meters. Newton meters. Capital N, simple Newton meters. Okay. Okay. How long you want to pay? Quickly write it down. And then let's go to the tube. In the tube, you have a text box here, right? Fill it up. And you can see when we are writing the factors, we have to say magnitude of force and perpendicular distance to the line of action of the force and from the axis of rotation. Line of action of the force from the axis of rotation. Okay. Fill it up, please. Okay. So get this now. So moment is equal to F into d, right? Force when we take, we consider the direction as plus minus, correct? If the force is applied in one direction, you take plus. Opposite direction should be minus. Moving upward, if it is plus, downward should be minus. West plus means east minus. East plus means west minus. That is how we do. But for the moment, we can't take a linear direction. We can't take a linear direction for moments. Okay. What we take here is a turning direction or rotational direction. Rotational direction. So the direction goes in this way. Look at this. This is the point where it is fixed. I'll take the point as O. Okay. If the rotation you're gonna take into this direction, this is the direction the clock hands are moving. This is the direction the clock hands are moving. Okay. So this clock hands moving direction we term as the clockwise direction. What is the direction? Clockwise. 1, 2, 3, 4, 5, 6, 7 up to 12. It's moving right. It is the clockwise direction. Okay. So this direction I can give it in this way. I'll give a force A here and B here. Can you see when the hands moving to clockwise, A is also in the same direction, right? Can you see that? That means when you are moving it around like this clockwise, to the same direction only A is active. Correct? If you're gonna take like here, when you come down, A is acting downwards. And furthermore, when you come down, B is also acting downwards. Okay? And let me take to the other side now. At once. This is a point O. And now I'm giving a force here, C, and here, D. What about the C and D? You come down here, A is downward, B is also downward. When the other side, when clockwise goes up, C is up, D is also up. Correct? So can you see all A, B, C, D in this diagram? All A, B, C, D in this diagram is in the same direction. I'll repeat it again. When you take the clockwise direction to this, okay? When you move here, A comes down, correct? B also comes down. C goes up, D goes up. Correct? Same direction. Same direction. Did you understand that point? If you don't understand that, the lesson will be hard. Clockwise, A is in the same direction. All A, B, C, D here, as I have applied, is the same direction. So you see, the side doesn't matter. Up or down. Above the rod or below the rod, or right side or left side, doesn't matter. But I use the word for you to recognize. Otherwise, I can't say this and that, right? So I will use the word left side, right side. But the sides doesn't matter. Whatever the side the force is applied, the direction matters. What is the direction you apply the force? If it is clockwise, you take it plus. Got it? Now let's say I'm gonna take another. Right? Same way it is fixed. Now I'm going to give the force in this way. I'll mark it as EFGH. Now can you see? I'm taking the reverse side. That means anti-clockwise. But clockwise? Anti-clockwise. That means 12, 11, 10, 9, 8, backward, reverse. Reverse. So reverse direction anti. Can you see when you move backward, reverse, G is in the same direction, right? H is also in the same direction, right? You understand that? Okay. So when you move like at the shadow and the direction given here, it moves down. And H is also moving down. And when from this side, E goes up, F goes up. And that is the anti-clockwise direction. Is that clear? Clear? So again, anti-clockwise should be moving reversed of clock. Reversed of the clock, this is the direction of anti-clockwise. So this is the direction of anti-clockwise. Okay. So when it is moving there, you can see from the point where it is fixed, G goes to the opposite direction. H goes to the opposite direction, E goes to the opposite direction, F goes to the opposite direction of clockwise. That means all of them are anti-clockwise. Did you understand that point? Clear the point? So simply, when you move like, okay, when you take it this way, okay, this way, this is clockwise. Correct? This is the direction, clock hands are moving clockwise. If the force above this horizontal line, if the forces are given to this angle, okay, to this way, if the forces are directed, so the force up comes down, goes down, up, up. Got it? So simply clockwise. Opposite direction, anti-clockwise. Is that clear? Opposite direction, anti-clockwise. So that is how you take the clockwise and anti-clockwise direction. Okay. So you see, this direction matters when we find the answers, when we write the answers for moment. So this is clockwise. And what is this? Anti-clockwise. Who's clockwise? Anti-clockwise. Right? Anti-clockwise. Right? So clockwise, anti-clockwise moments we take, and when we write the answers, we have to mention which direction you take as. Which direction you take it as. Right? So we are going to do some questions accordingly. One. Same way I'm going to give you the question, but simple to advanced we're gonna take. Okay. Point O. I have a force here. The force is acting over there, 100 Newton, and the distance is 2 meters. Okay. How do we take the moment? We take the moment here clockwise, and this is the direction. Direction, right? This is the clockwise direction, right? So how do we write? Look at the step. First, I'm writing clockwise moment around O. Or even I can write without the word clockwise moment, and I'm showing the direction. Moment is equal to F into D. You have to write the formula first. Now, you see this is in the clockwise direction, right? You can see this is the clockwise direction. So clockwise direction only I have 100 newtons. So I'm writing 100 newtons into what is the distance? 2 meters. 100 newton into 2 meters. So 100 into 2, it is 200 Newton meters. 200 Newton meters. So simple 100 into 2, 200 Newton meters. Okay. Only thing is direction you have to check. And number 2. Let's say it's fixed in this way. Point O. It is not always point O. Any letters you can take. I'm just taking point. And now here the force is given downwards 200 meters. And the gap is 3 meters. 3 meters. Now you see it's not must always to be at the end. Anywhere it may be. Any distance it may be, any forces it might be. Any direction. We have to just check out with the points. We have to write. Now can you see? If you consider this, tell me this 200 meter, is it clockwise or anti-clockwise? Anti-clockwise. It's clear to you, right? It's anti-clockwise. Because this is the anti-clockwise direction. That is the direction 200 meter is active. I can give the answer in 2 ways. Okay. Let's say, as my opinion, I take clockwise. Always I'm taking clockwise, let's say. So the clockwise moment should be to this direction, right? F into D. But my force is in the anti-clockwise direction, right? I start my answer as clockwise, but my force is in anti-clockwise. Should it be plus or minus? Minus. Did you understand that point? Point clear? So minus, how much is it? 200 into 3 meters. Always between the point where it is fixed, where it is inverted, and to the point where the force is active. So answer shall be minus 600 Newton meters minus K because I took clockwise. So if you take clockwise, answer is minus. Let's say if you write anti-clockwise in your answer, at the beginning itself you are taking the direction anti-clockwise. Now what do you think the answer is? It has to be plus. Why? Anti-clockwise is in the opposite direction. So anti-clockwise is my direction I consider. Force is also in the same anti-clockwise direction. So I don't want to take minus. I can write straight away. 200 Newton is plus into 3 meters. 600 Newton meters I can. Got the point? 600 Newton meters I can write. Clear the point? Okay. So this is clockwise and anti-clockwise. Okay. One more example. $350 Newton 100 centimeters. Okay. Now we can see it is clockwise, right? It is clockwise. Clockwise I will take around F into D. How much is the force? 350. What is the distance? Centimeters, it's 100. Can I apply 100 centimeters? Can I apply 100 centimeters? No. It has to be meters. How do I do that? Dividing by 100. 1000. Dividing by 100 to make it meters. Centimeters to convert into meters, dividing by 100. Correct? So 100 over 100 is 1, right? 1 into 350, 350 Newton meters. Correct? Got it? Several ways the question could come. One by one I am giving you. I told you simple to advanced we are heading up. Okay. Number 4. A 5 kilogram object is kept at a distance of 2 meters. By the weight of this object, what is the moment acting? You can see weight will be always down. Yes? It is clockwise or anti-clockwise? Clockwise. It is clockwise, right? It's moving down, right? For the clockwise direction. So I have to write it as clockwise moment around O. F into D. How much is F? 5 kg. Can I write 5 kg? Can I write 5 kg? 5 times 10. 5 times 10. Why? Kilograms to convert into newtons. I have to give the force. So 5 into 10 newtons. How so? Oh, straight away we can write 50 newtons. Better you show them. Into what's the gap? 2 meters. Let's say the gap is not up to here, you can't take. It has to be between. Right? From the center of point only the force is acting down. The weight will be acting down from the center. Okay? So 5 into 10, 50 into 2, 100 Newton meters. Understood? Is that clear? Clear the points? Fine. So we're gonna write it down. On a writing note, take this as the note first. This is the point you have to concern with the direction. Okay. And then we are going to copy this down. Further some questions I'll be writing where you have to write answers. Get me the answers for these questions as well. Okay. Don't spend a lot of time. Mark this properly and the rest of the cards you can roughly draw. You don't want to use the rulers for this, okay? Don't use the rulers, it takes time. Just roughly do. Okay? But this better you use a ruler because it's a theoretical part. It's a theoretical part. Mark it properly. Please go ahead. Oh. Is to complete it. Yeah. Wait me. A big doubt here, sir. Okay, quietly do it. Finished? All? Question 5, is it 50? Yeah, 50 centimeters. I think this is not visible, right? 50 centimeters. 250 grams, 50 centimeters. Question 5. 250 grams, 50 centimeters. Okay. Yes, I mean, better you write because you have to practice. It's not must. Because since we are showing the direction here, it is not must, but still you write to practice. I want everyone to write the same way. Okay. Because you have to practice, you have to remember what is clockwise and anti-clockwise. Anyone didn't get your papers yet? Yes. Seventh one, there are two mass, okay? Two masses attached. Onliners, you can forward your answers.
3.5 meters or 35 meters. Yeah. Consistent. Sir, is it 3.5 meters or 25 meters?
3.5 meters. It's 3.5 meters. Onliners can forward your answers. I don't think so, Amnath. Ramla, Rukia, can you see the board clearly? Is the board visible? I think only this place is not clear because of that light. Yeah, Rukia, is that clear to you? Ramla says yes. Only this place won't be clear because of the light. Other areas, can you see the terms? Yes. Okay. Amnath, could you please check again? Turn off and on the video and just check again, please. Sixth and the seventh one. Okay. Oh, yeah. How about now? Question 6, it is 3.5 meters and 300 newtons. 3.5 meters, 300 meters. That's not 35, 335. Amar, can I please write this? These specific papers marks. Chemical discipline. Most of the station the skill what for the last line. English. All 450 dividends. That 50 centimeters. 50 centimeters. 14 different. 50 divided by 100. 50 divided by 100. Right again. and 250 grams is gram here. This grams how to convert the grams? Grams if it is given, we have to convert into kilograms. You are given by thousand. Okay. And then you want to convert into newtons multiplied by 10. So 250 grams now divided by 1000. Okay. So then you want to multiply 10 to 80. Then when you have to get 250 into distance. Is 250. Distance is 50 centimeters. How to convert centimeters? Centimeters and convert to meters. Divided by 100 is 1 by 2. This correct using the also. Right? 2.5. Question 5. It is a clockwise moment, right? Clockwise moment around O. Around O. Now it is F into D. F into D. Is it giving you the Newton here? No, right? It's giving you the grams. It's giving you the grams. So what are you supposed to do to convert the grams into Newton? Grams to convert into kilograms. So how to divide by 1000 first? What are you supposed to do? Dividing by 1000. And then kilograms to convert into Newton. You have to multiply by 10. Right? So 250 grams dividing by 1000 into 10, it is the Newton. You can't straight away write 250 Newton. It's not 250 Newton. 250 grams given. So divided by 1000 into what is the distance given? 50 centimeters. How do you convert centimeters? Centimeters to convert into meters, you have to divide by 100. So 50 over 100, it is the meter. How much do you get? 2500 dividing by 1000, it is 2.5. 2.5 into 0.5, no?
Yes.
How much is it? 0.125? Oh, 1.25. $12.5. 12.5.
1 over 2.
12.5. Clockwise only Newton meters. 12.5 Newton meters. Okay. Question 6. Now tell me, is it clockwise or anti-clockwise? This is anti-clockwise, right? Anti-clockwise moment. And that is to this direction. Oh, sorry, clockwise. Clockwise. It is clockwise. Not anti-clockwise, clockwise. Okay. Clockwise. F into D. What is F? 300 Newton into what is the distance? 3.5 meters. How much is it? 2? 1050. 300, 900, 150, 1050. Yes. 1050 Newton meters. 1050 Newton meters. What about the question 7? Question 7, clockwise, right? Around O. You have 3 kilograms plus 1 kilogram. Totally 4 kilograms, right? 3 plus 1 kilograms into 10. newtons. Correct? 3 plus 1 kilograms into 10 to make it newtons. Into what is the gap? 3 meters. So it is 40 newton into 3. 40, no? 4 plus, this is 4, 4 into 10, 40, 40 into 3, 120 newton meter. 120 newton meters. Is that clear about the theory now? Totally clear, right? Fine. So this is about the moment. Yes. That is about the moment. Point. Did you guys calculate the seventh one, fifth one properly? Is it 12.55 or 1.25? Let me check. 1050 or 0.2. Yeah, it is not 12.5. 1.25. 1.25. Okay. Yeah, 1.25. How? It's not 12.5, it's 1.25. Yeah. Last one. Sixth one. Yeah, what is the answer you are giving me? I'm writing there. Check if it is correct. Calculation. We have read the 900. 1,000? 60. No. Check it out. It's not 1,650, 1,050.
If it's 2500, then
1,050. Right? Where is that 6 came from? 1,650. And what is that 1,650? Right. We move to the next one. Now the relationship between the fractions, okay? The relationship between the fractions. Our formula is F into D, right? Moment equals F into D. Okay, moment equals F into D. Now I'm going to build up 3 relationships. Actually, these things you must do. You must do these things. Okay. It is a student analysis work. But still, I'm helping you to do it. Okay. Otherwise, this has to be repeated in every equation. What I'm going to speak about here is common for all the equations. Okay. You should be able to compare, analyze the factors in an equation in a formula. That goes like this. Moment equals F into D. Let's say in an instance, if F is constant, who is constant? F is kept constant. Force is a constant value. You don't change the force. Without changing the force, how these two are impacting on one another. Since it is of either side of the equal mark, this person is not changing. Moment and distance are both sides of the equal mark and both of them are numerators, right? Both of them are numerators. Either side of the equal mark, both of them are numerators, means you have to take them directly as proportional. What proportional? Direct proportional. Moment is directly proportional to distance. Means you increase the distance, moment increases. You decrease the distance, moment decreases. Now you know moment symbol we don't use in our level. In our level in grade 10 level, we don't use the symbol for moment. Otherwise, capital M we can give. Okay, but still you write the word moment, right? Moment is directly proportional to D. Means you keep the same force, you increase the distance, moment increases. You keep the same force, you decrease the distance, moment has to be decreased. That is the idea. We'll take some example. Second one. Let's say if you're gonna keep the distance constant, you're not changing the distance. Okay. In that case, distance constant means again these two either side, both sides of equal mark, both of them are numerators. This person is not changing, means both of them become directly proportional. Directly proportional means keeping the same distance, you increase the force, moment increases. You decrease the force, moment decreases. And the third one, let's say if the moment is constant, who is constant now? The moment is constant, you don't change the moment. Moment constant means now these two are in the same side. Okay, we'll say m is equal to f into d. Now this person constant means one person you have to take to the other side, right? To compare, or the same side people want to get compare. This is to get the same. You increase one, the other one should be decreased. So that it will be balanced. 2 into 10, 10 into 2. 2 became 10, 10 became 2. 1 is increasing, the other decreases. Then only 2 into 10, 10 into 2 becomes 20. You understand? Is that clear? So when one person is increasing, the other one decreases. Or else, let's say I take f here, d is equal to m over f. This person constant means either side of equal mark, one is numerator, the other one is denominator. Up and down. Up and down means inverse proportional. You understand that point? Up and down, either side of equal mark. One is numerator, the other one is denominator. One is above the line, the other one is below the line. This person is constant. So I can take force is inversely proportional to distance. What do you mean? You increase the distance, force decreases. You decrease the distance, force increases. Force increases. Is that clear? Okay. And some theories are there, guys. As a theory, might be now only you are learning, but you are practically doing that every day. Okay. Every day you used to open a door. Open and close a door, maybe a window or a drawer, right? So when you come for this point, usually you have the handle to the corner. Have you seen any doors? Have you the handle to the other corner where it is hinged up, where it is fixed up? Do you have the handle? We used to have the handle in one end, where the other end you have the hinge. So it is connected over there. So we open like this, correct? We open like this. So you see, the reason is hinges are fixed. You don't change that. Do you every day change it? No, it's fixed. Only once. Repairing is a different story. Right? So the moment is same, the turning effect is same. So moment, the third compression is moment to be same. If you decrease the distance, force increases. If you increase the distance, force decreases. So maximum distance you give, minimum force you need to open. Minimum distance you give, maximum force you need to open. Imagine the handle is there somewhere here at the center. Half of the distance you reduce, double the force you have to apply. So to make your work easier, applying a smaller force, maximum distance is taken. Maximum distance is taken, and that is why always when you come for the doors, windows, or any furniture doors, usually to have one end if it is a hinge away, it is connected, the other end you have the handle. Maximum distance is given. So maximum distance, minimum force. When the distance is reducing, the force you need becomes greater. Clear the point? Okay, so accordingly, okay, there's an activity. Example. You can see over there is a door. It's a door given here, right? So this door does have some parts. Can you see? Some parts are given in the diagram, right? You can see there. You are going to fix the Newton balance at different points, and this is the axle where it is fixed. You apply the force here, you are going to pull. Each point you are going to pull, right? Whom do you think you have to apply the smaller force to pull it? Is it A, B, C, D? Smaller force to pull? A. Why? Maximum distance is there from the point where it is fixed. So maximum distance, minimum force. So you compare them as the distances from this point. It is the distance dA and this is the distance dB. So let me take A, B, C, D. dA is the maximum and it reduces like this. Maximum distance means force you need would be minimum. Am I right? So who needs the greater force? And D, you have to apply the greater force to pull, which is half. So it becomes easier when you do the maximum distance, minimum. Clear the point? Clear the point? So this is one application where we apply this. Okay. So shall I write this down on your writing book, please? This part. Just write this in big letters, and below that, mark this down. These are the relationship, interaction between the factors. Make it fast.
Consideration economics
Yeah.
in any chapters in grade 10,
Means
like, like something to make it interesting. Yeah, any chemical compound,
are you going to do the exam also the same?
just telling all right,
You don't have practical exams, so no need to do the practicals, only the writing. All the practicals you have to
in the school there is something called science labs.
I think
We have steps in it.
then you have to ask them not to. Yeah, planning out with the practical session week. Waiting for it. Sure. Maybe probably within a month or two, we will have.
Same way to show previous.
No, there's an exhibition, right? Not that. Right? So go to your tude. Go to your tude. Take the first page of that lesson. Of that lesson, first page, maybe page number 8. 8. Page number 8. You have this diagram, right? The diagram's there, right? Below that, can you please write this? This part. Right. And two more questions are there below that. Can you see what are the two questions? Read. At which point you have to apply the force the maximum, right? Maximum. What is the point? The maximum force should be applied. Point D. Second one. What is the force? The maximum, the minimum force should be applied. What is the point? A. Please write there. And then we take another activity here. Look at this. You have a bar, a wooden bar, and you have a spring balance. A spring balance. This is fixed over there here, and you are going to pull it down. You are going to pull it down, right? At once you are not giving a bigger force. Slowly you apply a force at the 60 centimeters gap. 15, 30, 45, 60. 4 points are there. At 60 centimeters gap, you are going to pull it down. When you pull it slowly down, you mark what is the smaller force. What is the smallest force, the minimum force you need to pull it down. You are recording it. Let's say the force is 2 Newton. Force is 2 Newton. Now tell me, 2 Newton force you need at the maximum distance. How much force you need if you come to 30 centimeters? 1. You reduce the distance. So force should be increased, doubled up, right? It's not 1, it becomes 4. You understand that? Okay. So the distance maximum, minimum force, you reduce the distance by a half. Then the force becomes doubled up, 4 Newton. The distance you take to 15, 1/4 you take. Force becomes 4 times 8 newtons. You understand that? Force will be 8 newtons here. So accordingly, when you reduce the length, the distance between the points, and you apply the same spring balance, you can see you need a bigger force. Given the same 2 Newton, you can't move it down. You need the force more than that. Every point, this is the clear the point? Right. Now, then what do you do? In this activity, you are marking this 2 Newton, right? 2 Newton you mark. Afterwards, there's a nail here. This nail you are going to rotate. Half a turn you are rotating. Half a turn you are rotating to make it tighten. Okay? To make it tighten, half a turn you are rotating. Half a turn you are rotating to make it tighten means moment is it increasing or decreasing? Increases. Tightening, right? Tightening, turning effect should be increasing. Okay? So, when you tighten it, turning effect increases. Turning effect increases and you don't change the distance. Now we wrote 3 interactions, right? Tell me, if the distance is kept the same, when you increase the moment, what should be happening for the force? Should be increases. Should be increasing, right? So half a turn you change to make it tighten, increasing the moment at the same distance, you give the same 2 Newton. Can you move it down? You can't. Why? Moment has increased. Moment increased means you need to increase the force. So more than 2 Newton, now you have to give. According to this activity, somewhere about 5 Newton you have to give. It is not a fixed value, just a value. Just an example. 5 Newton. Now what do you do? Another half a turn you are going to tighten. That means almost a full turn you have tightened. That means the moment is increased. Moment is increased. Furthermore, the moment is increased means giving the same 2 Newton or 5 Newton, can you move it down? You can't. Why? Moment has been furthermore increased. Turning effect is furthermore increased. So you have to increase the force you need. So somewhere 9 Newtons you have to do. So it shows you that when you tighten it, moment increases. If you want to give the force at the same distance without changing the distance, you have to increase the force. Now, loosen that half a turn or full turn again. Do you need 9 Newton now? Get back to somewhere close to 2 Newton. Why? You have reduced the moment totally. So, force needed would be reducing. Do you understand that? Clear? For the same door, you are going to make it more tight, let's say. Would it be easy to open and close? It's hard. That's the idea. Okay. So, and the next activity we are going to do without changing the force. Without changing the force, we are going to change the distance. Moment the same way. Initial is somewhere about, okay, at 15 centimeters gap, I'm going to apply the force. I need 1.5 Newton. I need 1.5 Newton to move it down from the point A, 1.5, 15 centimeters. 15 centimeters. I'm increasing the moment, half a turn. Half a turn. Moment increase means keeping the same force. Tell me what should be happening for the distance. distance must be increased. Moment you increase, force same. The first interaction I gave, can you check? If force is constant, moment increase means distance should be increased. So, giving the same 1.5 Newton here, can you move it down? No, you have to increase the distance. So, slowly you are moving to my right. Somewhere when you come here, you can see giving the same 1.5 Newton, you can pull it down. You can rotate it down. So, it shows you if you increase the moment, without changing the force, if you want to pull it down, if you want to turn it down, you have to definitely increase the distance. So force constant, distance increase, moment increases. That's the first point. I'm summarizing. Look at your two. Look at your right and left. Three interactions, three relationships. What's the first one? Force constant. You increase the moment, distance increases. You decrease the moment, distance decreases. Decreases. Correct? What is the second one? Distance constant. You increase the moment, force increases. You decrease the moment, force decreases. Third one, moment constant. You increase the distance, force decreases. You decrease the distance, force increases. Clear the points? Is that totally clear about with the activities? Any questions here? Okay, right. So now, next we move into another type of calculation. Another type of calculation. Okay, what's that? The calculation goes up with finding the resultant. Let's put the topic on a writing book. Finding the resultant moment. Finding the resultant moments. So same directions we are going to use. I think the question number 8, right? Right. Finding the resultant. I told you simple. Step by step we are heading up. Okay. Earlier we took only one force, one distance, right? Now I'm going to take 2, 3 at once. Right? Now, tell me this 10 Newton. Is it clockwise or anti-clockwise? 30 Newton. Clockwise, right? Both of them are moving to the same direction of clockwise, right? So both I have to take plus. Both I have to take it as plus. So let me write now. Let me use the word resultant moment. And my considered direction is clockwise. Earlier we used the word clockwise, anti-clockwise. Now I'm straight away taking the resultant momentum. I'm changing I'm taking the direction around O clockwise. So accordingly, plus minus I take. Because it's 10 Newton is plus, same direction. F into D. 10 into, what is the gap? This is the line of action of 10. This is the point where it is fixed. Okay. Actually, I have to take the point somewhere here, closer, so that I can take this distance. Okay. 2 meters. And it is a plus. Again, I have 30 Newton. I don't take at once 10 plus 30, 40 Newton, I can't take. And 2 plus 3, 5 meters, I can't take. One by one. Something like 2 people are hanging here. Both the people are giving 2 different moments. Both the people's moments separately, you have to find and you have to add them. You have to add them. So accordingly, 10 Newton into 2 and 30 Newton into how much? 30 Newton into? Is it 2, 3 or 5? 5 meters. Why 5? Starting point 2. Ending point where the force is acting. It's not 3. The total gap it is 5. So how much is it? 10 into 2, 20.
20
30 into 5, 150, right?
100
170 Newton meters. It is a plus arm, so that means clockwise is the move. Clockwise is the result. Okay. It is hanging over there here. Okay. I have a force 50 Newton at a distance of 2 meters. At 1 meter, I have another force, 50 Newton. Okay. I want to find out the resultant moment. Help me out. I take my direction as clockwise around 2. This is my direction. Okay. This 50 Newton. Is it clockwise or anti-clockwise? Tell me quickly. Is it clockwise or anti-clockwise? What about this 50 Newton? Anti-clockwise. Is that clear about the anti-clockwise? Now, how do I take? This has to be a plus. This has to be a minus. So, 50 Newton into, what is the gap? 2 meters. Minus. Again 50 Newton into. Do I take 3 meters down? No. From this point, where is fixed. Gap is 1 meter. This is the point where is fixed, right? This is 2 meters, this 1 meter. So we don't take the total here, okay? That's a different story because this is ending point. Okay? From one end to the other. And now 50 into 2, 100.
100 minus
Minus 50 into 1,
50.
So what is my answer? 50. Tell me, is it clockwise or anti-clockwise answer? Plus no? Answer plus means my direction is clockwise, so clockwise should be the result. Is that clear? Clear the point? Go ahead.
Yes.
Get me the answers. Eleventh one, you have three weights giving the masses. Okay. First one is 7 kilograms, and then 2 kilograms, and then 1500 grams. 1500 grams. Okay. Distance are also accordingly given. You have to calculate some. You have to find out the distances and the weights actually. Please do it properly. A set of questions are waiting for you to be done. Not now. Later I'll be giving you as a set of paper. Okay, set of questions will be given out of these forms. You have to practice, otherwise you will forget. What's wrong? Could you finish it up, Rakib? Done? Make it fast. Okay. How about this one? Question 10. The resultant moment heading around O clockwise. Help me out. 200 Newton is it clockwise or anti-clockwise? Around this point, this is a point O. Around this, is this clockwise or anti-clockwise? Help me here. Boys? Plus or minus?
Yes.
What about this?
Minus.
Minus anti-clockwise. Got it? Right? What about this? What about this? Clockwise anti-clockwise? 150 Newton. Minus anti-clockwise. Why? You see, this is the clockwise, right? And this goes down. So it is anti-clockwise minus. Got it? Is it clear? Anti-clockwise. Right? So resultant moment equals. Now let me take one by one. I'll take this first. 200 Newton into what is the gap? 3 meters. And then again I have a minus 100 Newton into what is the gap? Is it 5? 6 meters. Again, I have 100, 150. Let me write the 150 here. Into, what is the gap? 2 meters, correct? Correct? 200 Newton into 3 meters, 600 Newton meters. Minus 100 to 600 Newton meters. Minus 150 to 2, 300 Newton meters. 600 to 600 cancels off, plus minus. What is remaining now? Minus 300. So what is the resultant? Minus 300 Newton meters. So to the clockwise, you get a minus also means turning effect, the moment is actually in which direction? Anti-clockwise. So because minus also means actually the resultant is in the opposite direction. Opposite direction. Again, the resultant moment. Okay, help me out. 2 kilograms clockwise and anti-clockwise. 2 kilograms clockwise, right? Plus 1,500 grams clockwise. 7 kilograms anti-clockwise minus. So how do I take? Let me start from. You can start anywhere from, but it's easy when you go in an order. So here I took only starting from 200. So let's say I'm starting from 7. 7 is anti-clockwise, right? So I'll make it right here. Minus 7 into 10 I have to take, correct? Correct? Why? 7 kilograms, right? Kilograms I have to take it as Newton multiplied by 10. So minus 7 into 10 into, what is the gap? 5 meters, correct? From here, 7 kilograms a half. 1 kilogram is equal to 10 kilograms. 7 into 10. That's Newton. Gap is 5 meters. Okay? Correct? Then I have 2 kilograms disperse. So I make it as 2 into 10 Newton. 2 into 10 Newton into, what is the gap? 2 meters. Why? Total 5. This part 3 means what is the remaining? 2 meters. So into 2 meters. Again plus. Now I have 1,500 grams. 1,500 grams means dividing by 1,000 and then multiplying by 10 to the negative Newton, correct? 1,500 grams means 1.5 kilograms, right? 1.5 kilograms into 10, 15 newtons. 15 newtons. 15 newtons into, what's the gap now? 5 meters. 5 meters. Okay. Correct? Did you get them? Get them properly? Right? 770 into 5, 350 Newton meters, that is minus. Plus 2 into 10, 20 into 40 Newton meters plus 1,500 1.5 into 10, 15, 15 into 5, it is 75 and it is also plus. So 40 plus 75, 115. What is the remaining? What is the remaining? 235, is that so? 235, right? 235, yes, 235. Yes, 235. And it has to be minus. Check if it is correct. Check if it is correct. Okay. Did you understand the lesson now? Is that totally clear? Clear? So you have to practice all these questions, okay? All these questions you have to practice. So first we took only one direction. Either clockwise or anti-clockwise, only one single force we took. And then clockwise, anti-clockwise we mixed. And now we took the resultant. This is the type of question come in the paper. They ask you to find out the resultant. Related to moment, find out the result. Another type of question, finding out one of the factors. One of the factors, maybe one force or one distance, they will ask. And that comes under equilibrium. That's the next part I have to do. That is coming under equilibrium, balancing. Balancing. So let's take the topic. Direction of the moment. Okay. This is not needed now. Direction of the moment of force and equilibrium. What do you mean by equilibrium? The last thing is what do you mean? Equilibrium means not moving. Simple. It's rest. Rest. Under forces, under the resultant force, we learn opposite directed forces equal means one side 50 Newton, one direction 50 Newton, not the side, one direction 50 Newton, opposite direction 50 Newton force means object will be balanced. Why? 50 plus 50 minus 50 0. Plus 100 minus 100 0. Plus 1000 minus 1000 0. Opposite forces are equal. Right? Resultant force 0 means object will be at rest. Resultant force 0 means object will be at rest. It is at equilibrium. That is one method of being rest. Second method of being rest, if the resultant moment becomes 0, that means clockwise moment become equals to anti-clockwise moment. Total clockwise moment becomes equal to the total anti-clockwise moments. Then resultant is 0. 100 Newton meters minus 100 Newton meters. 500 Newton meters minus 500 Newton meters. Zero result. Resultant moment becomes 0 means object will be at rest. Object is at equilibrium. You got the point? Okay, so accordingly, such an example given. You can see there here. You have a rod. You have a rod clamp, and this rod has a distance either side d1. It is d1 from the point here, and the force given here is F1. And the force given here is F2 at a gap of D2. Okay? Clockwise moment. What is the clockwise moment? This is the clockwise direction, right? Clockwise you have F1 at a distance of D1. So F1, D1. Anti-clockwise, opposite direction, F2 into D2. F2 into D2. And it says, when the two forces are applied at the same time, the resultant moment. How to find out the resultant? If clockwise is plus, anti-clockwise should be minus. So F1 D1 clockwise minus F2 D2 anti-clockwise. Clockwise minus anti-clockwise is the result. Okay? Clockwise minus anti-clockwise is the result. Now let's say both clockwise and anti-clockwise are equal. 100 to 100, 1000 to 1000, 200 to 200. Then the result will be 0. So F1 D1 equals F2 D2 means resultant moment. Now already we learned how to find out the resultant. So if the oppositely directed moments are equal, resultant moment is 0. So if the resultant moment becomes 0, object will be at rest. It is at equilibrium, no more motion. No more motion. Okay, did you understand that? So it is balanced, we say. Object is balanced. So the point here is resultant moment 0 means clockwise moment should be equal to anti-clockwise. So clockwise moment becomes equal to anti-clockwise moment means reverse. Resultant should be 0. Did you understand? Is that point clear? Clear? Right. So let's write this down. Go to the tube, please. And write the word resultant moment and highlight the last statement. Object will not rotate, will be in equilibrium. Highlight that point. It depends. Part 2 basically start as an activity it might come or as a part of the motion question, forces motion. Part 1 MCQs it will be. Parts will be. Short hard. We are going to end up.
Second.
We are going to end up.
That's my thing.
I'll give a good break after 10 minutes. 1 week break you will get after 10 minutes. Right, done? Done? Not done.
Yeah.
I want 1 minute break. 60 seconds break. Sorry, 60 seconds finished.
Say
Fine. Look at the question now. The last one. Last one. We have just 2 hours, man. In these 2 hours, also half an hour break. If you are getting, what is the use of having the class for 2 hours? Okay. Huh? 40 minutes into 5 days, Namati. No? Sometimes double period is also there. Mocking periods are also there. So this is only just 2 hours for a week. So we have to do. I told you right. This is not a class where you can have fun. You're not coming for fun, right? Are you? Is that your mother, father paying for fun?
Yeah.
Go to sit next to the science class, have some fun and come. Is that so? If you are saying, I'll ask your father mother. Then I'll agree with him. Is there anyone? No. Then fine. Okay. Anyhow, I am smiling with you all. Sometimes you are getting a short break to relax yourself. Okay, we go ahead. Otherwise, we can't do. Okay. So you know about that, right? I don't like to just go ahead roughly, right? Every part I'll explain here why you have to understand. Otherwise, do I need to do all these types of questions? Think about your school. Have you done all these? No, right? 1 or 2 examples are do the exercise. That's what happening. Why the hell I want to do all these things? Okay. See. Why? You have to understand properly. Otherwise, how many questions will it see? And some more questions are remaining for you to practice and prove. Because practice make you perfect. Still, you can't be perfect. Try to be. You have to lead towards it. So that is what. If you say no, sir, we don't go on, let it be. I'll just pass and go. Shall I do like that? No. Not for that, not for this both. No. What shall I do? Okay, so we'll balance and go ahead. Okay. Fine. Good. After 10 minutes, please. Right. Yeah. Go. Drink and come. Go. You sing it. If a weight of 4 Newton is now suspended, now you see, this part also have made easy for you. This question also, the 3 more questions are there on your note. I have made easy giving the diagrams. Otherwise, you have to draw the diagrams. Yes. Okay, so you see, look at this. Question says it is a rod. Now, how do you draw diagram? Look at this. How do you draw diagram? A uniform rod of AB. Let me draw. AB is a uniform rod. AB. Okay. Balance at the center. Balance at the center. So this should be the center point. Okay. The method of drawing. Okay. 1 meter length, 1 meter long means center balance refers to either side should be 0.5 meters. Am I correct? Half a meter, right? Yeah. Now it is balanced. It is balanced. A uniform rod means throughout the same density is there. Same uniform mass is there. So it will be balanced at the center. Then what do you do? First question says that if a weight of 4 Newton, if a weight of 4 Newton is hanging from the point B, this is the point B, you are going to hang down 4 Newton. 4 Newtons. Okay. Find the clockwise moment. How do you find out the clockwise moment now? Now look at this clockwise moment around whom you take. Is it A, B, or O? Around O. Because point where it is fixed. We don't take A or B here. We take O. Around O. We take. Right? Because that is a pivotal point. That's the point where it is fixed. Around O when we take, we have only 4 Newtons still. I don't take all these things. I have only 4 Newtons. So 4 Newton is clockwise, right? Around O, F into D, I have 4 Newton into, what is the gap? 0.5 meters. 4 into 0.5, 2 Newton meters. What is the clockwise moment? 2 Newton meters. 2 Newton meters. Then the question says, now you are giving 4 Newton. Would it be balanced further? No, it has gone like this now. Correct? Because earlier it was balanced. Now you are giving a force of 4 Newton, it goes down. You want to balance it back again. If you want to balance, you have to give a force. Is it in the same direction, opposite direction? Opposite direction. You have to balance it, right? Why? Clockwise should be equal to, not clockwise, anti-clockwise. Clockwise should be equal to anti-clockwise. So if it goes unbalanced in one direction, opposite direction, you have to give the force. Opposite direction, the total moment should be acting on. So the question says, if the weight of 4 Newton is kept at B, what is the weight suspended from the point C situated 0.4 meters away from the center? Away from the center. Either side you can take. Okay? Either side you can take. But since it is a weight, you can't give the force from above the bar, right? You have to give it down. So either in this way, in this side, like down, or this side, down you can take. But the gap should be how much? 0.4 meters. 0.4 meters. Question says 0.4 meters away. So this is the weight here. And this is the point C. Understand? Point C. We take the point A, point C. Do you understand that? So if you take to the other side, you have to take it down. You can't take it upward. Okay? Anyhow. Sorry, you can't take it downward, you have to take it upward to balance. Because downward means it is clockwise, it won't be anti-clockwise. Upward means it is anti-clockwise, but you can't take. Why? Weight won't be acting upward, weight will be acting downward. So definitely you have to take to this left side. You understand my point? Okay, right. Now, since I'll repeat it again, you want to balance it. Opposite direction, you have to hang down the force. Okay. This opposite direction, it is not must for you to take to the left side. Even here you can give. If you are giving to this side, you have to give it up so that it would be anti-clockwise, correct? So that it would be anti-clockwise. But I can't apply like that at 0.4 meters. Why? It is a weight. It is not a just upward force. Question says it's a what weight is suspended. Weight should be always downwards, right? Weight cannot be upward. So Nice, two birds are there. Right. See there. Okay. So the weight should be downwards so that we take the weight here. We take here. Okay. So you see, this weight is what I want to find. Look at the method of writing. This method is what you have to follow up in the next questions. Question says, would balance the rod again to make it equilibrium, to balance the rod again, to make it rested. So, to balance the rod or else to make it equilibrium, resultant moment should be equal to 0. Resultant moment should be equal to 0. If we want to balance the rod again, resultant moment should be equal to 0. If the resultant moment is 0, what the moment should be equal? Clockwise moment should be equal to anti-clockwise moment. Clockwise moment is equal to anti-clockwise moment. Okay. Now, for every question you write these three. Let me tell you this. It's not must. Then we don't want to write, don't take that. Sometimes at school, they say you don't need to write this. Fine. You don't write it, you will forget. Why the next time come, you don't do. Because the question doesn't say all these things, right? They directly ask you what is the force you need to balance it. How do you know how to find them? You have to practice yourself, write it in every question. Because every time you write, it goes to your mind, you understand this is why you take the next step. Otherwise, you don't know how come anti-clockwise becomes equal to clockwise, right? To balance the rod, resultant should be 0. I told you earlier, there are 2 points of they can be rested. One, resultant force is 0, the other, resultant moment is 0. So resultant moment 0 means clockwise equals anti-clockwise. So now I am writing. Clockwise moment already found, right? 2 Newton meters equal. Who is my anti-clockwise? W into, what is the gap? Is it 0.5 or 0.4? 0.4. 0.5 is the gap here to A, point to C, point C, 0.4. Now, I divide both the sides by 0.5, both the sides, 0.5. W should be equal to how much? 2 over 0.4. How much is it? 5. 5 newtons. So what is the weight? 5 newtons. Did you understand? Clear? So what did we just do? Clockwise moment we made equal to anti-clockwise moment. That means F1 D1 is equal to F2 D2. F1 D1 is equal to F2 D2. So F1 D1 already be found, right? 2 Newton meters. F2 D2 W into 0.4. Now I want to find out W. 0.4. I take the other side or divide both the sides. I'll get the answer. Fine. Now you are stuck here. Why? You don't know how to divide the distance. That's the problem. Because we want 2s is 2s? So this is the way you write, is it? I was thinking how is that if you have no, you have to come up from the sleeping mode, that's not. Is it? I know this. Okay, let it be set. Fine. Right? Did you understand the lesson now? Clear the point? Okay, we'll write it down quickly. Okay, right. Right, man? Finish writing. Fine. You got 3 more questions as a homework on your tute, right? Please make sure you write all those answers. Okay? Write with steps. Don't come without writing with excuses. So, 3 questions are there. Diagrams given for you to make it easier. But yet, check if the diagrams are suiting with the required questions. Okay? 3 of them are there. Last one, you find this is not what we are doing now. Previous one, resultant moment. Resultant moment is what supposed to be found in the fourth one. Okay? Resultant moment is what supposed to be found in the fourth one. Okay? Find the resultant moment for the fourth. Right? Fine. Any questions? How many of you have done this e-test? This week's e-test. Azil, you didn't do? Why? But next e-test, if you don't do, you are not allowed to the class. Okay? Got it? Amar? What? You don't know? How many e-tests you did? None, right? When? Still not in the group. When? For me? Drop me a message for the third time also then. Rehan? Didn't do. Rakib? Every week you are giving me a reason. No. Every week you give me a reason. Right. Next week, you guys, if you haven't done the e-test, okay, at the next class you are getting a punishment. Remember that? Okay, I'll give a nice punishment. Sure. Including the girls who are not doing. Then we read. Okay. Next week, if something broken, your bone would be broken here. Careful. At least a teeth would be. No one would be coming and asking here. You know that, right? Fine. Okay, you can leave. Please do the e-test and come, okay? Say then. Okay, we're ending up. Yeah, I'm Slam. Slam. Ramna, yes, you have to write it on the tute, okay? I'm Slam.